This is a remedial map reading lesson regarding the marginal data found on topographic broadsheets. It will not qualify you to go bushwalking. So don't use this alone as a means to go navigate somewhere. It's meant to gap fill a skill set with a discrete number of people in a discrete area. Next, we have, now, this particular lesson is a subset of a larger set of lessons not to be delivered here, and it is in response to people who have requested a remedial session in this particular area of work. It's not meant to be patronizing. It's meant to be delivered at really entry-level material for those who have not had exposure to map reading material before, and it is very rudimentary. If you find that you don't need this, great. If you're finding you're getting stuff that is revision for you, just read it a little faster, okay? If it's not for you, that's good too. But for those people for whom it is delivered, this is in no way, shape nor form patronizing, and no one's blaming you for not having the skill set, right? If you haven't been given a lesson, how can you know what you don't know? Okay, this is a map. In particular, this is a topographic map. Now, I'm going to cut this in half in simple terms, that there is the big picture bit and there's the not picture bit that shows other stuff that is, and you need both of them to read it. Okay, now this happens to be the 100,000 K map for, well, the 1 to 100,000 map for Cairns. Well, we know there's the label, that's the name of the map, and we've got a scale here that will tell you that's the 1 to 100,000. The really interesting things or important for us will be, during this lesson, the legend, the north points, and the blue bits and the not blue bits. Now, quite seriously, it's that hard. The blue bits and the not blue bits. Okay, so there's another part that will help you. The grid. If we go back here, you can see that there's a lot of little squares like an Excel sheet cast overlaid on this map, and if I expanded this, which I can't, the eastings at the top and the bottom increase in an easterly direction. The northings increase in a northerly direction on the left and the right. Where those two sets of lines intersect, you have a Cartesian grid or a square. Now we can identify individual squares by their numbers, or a group of individual squares by a different sequence of numbers, or a subset of those squares by, again, a different sequence of numbers, all derived from these numbers at the top, bottom, left and right. Now, they are called eastings and northings because they are numbered in sequence to the east and to the north. Now, with the grids, you can issue, or you can create, a 20-figure grid reference out of this map that actually narrows it down to a single square meter on the planet. Quite possible. Particular types of people use that level of increment to look for particular types of things. Now, graves, for instance, or surveyors who are looking for artifacts might know where there's a known area, and they'll need it to be down to that 20-figure grid reference. The US Coast Guard and the US Air Force that actually control the civilian and the military navigation satellites test their kit, and the last time I was talking to them, they did a test, global wide test in a competition, and they could narrow it down to 0.75 of a square meter. Now that's really accurate from a surveying point of view. Okay, less than a square meter, that's how good these lads are. And ladies, of course. Okay, I got to stop mid-stride. I forgot to start by acknowledging country. I'm teaching this from Gimoy, which is Cairns. I'm a guest on country, and as such, I acknowledge elders past, present and emerging, and do so as a guest on country with all respects accordingly paid. Now, There's something that is of interest. It is the scale. Now we won't cover scale in this lesson, but it is an indicator of the size. Okay, and guess what? There are north points, and there are 3 north points, and the legend. Now the legend that we looked at earlier, which is here, is like an index to a book, but it's a translation tool as well. So that gives you words to match pictures on the map. So different types of water, swamps, creeks, ocean. Just notice here in broad pictures, the green bits are not so probably heavy. Knowing this part of the world, it's jungle. The browny bits there are hills. Okay, that's actually the Kuranda Range. If you look, there's a ridge line there that we locally refer to as going over the bump, over the Yarrabah, which is an indigenous community out of Cairns. There's Cairns, Yarrabah is southeast of us. Okay, but this is the legend, and this is the north point, and there are 3 north points. Let's come back to the north points. North points. Okay, that's what the north point looks like. You have grid north. Now grid north matches up with the line of those vertical lines out of the grid. True north is where Santa Claus lives. Magnetic north is where you will point your compass, or where your compass will point to. Okay? Now notice there's a big difference. The reason why there's a difference between true north, off to Santa Claus's house, or magnetic north, Santa Claus's house being at the North Pole, as most of us would know, being in a November month. Magnetic north points you towards the magnetic pole, and the magnetic pole is not stationary. It moves. And if you look at this, there's a correction formula here. Again, way beyond the requirements of the course, but when you come down to orientating your map, use magnetic north. Okay, and because the movement of the North Pole is predictable, there's a means by which you can calculate that dates after the map has been published, and you adjust your bearing taking process accordingly, way beyond the scope of this course. Okay, the very first thing you do with a map when you're going to use it for anything, if you have to use it to find a place or be directional for navigation, orienteering type work, never ever skip this next step. And I'm saying that because I've seen it done. You have to orientate the map. So you make sure that the magnetic north point on your map is either overlaid or runs parallel to the magnetic direction as indicated by a compass. Make sure that the pointy bit of the arrow on the compass that has an N on it is facing in the same direction as the pointy bit on the map with the N on it, or the arrow on it. And why do I say this? Because I've seen it done the other way. And quite literally, you'll be facing the wrong way and be walking south instead of north, and subsequently you won't be looking at what you're expecting to. You'll be lost, or geographically dislocated, as we would rather say. It's possible that maps are wrong, but again, that's beyond the scope of the course. Okay, the thing is, most compasses are magnetic. So if you're going to orientate your map, are you doing it on the bonnet of a car? Because there's a dirty great chunk of iron under the bonnet and the car itself, and that will make your compass waver away from north. I've seen compasses literally circle when they're too close to a big chunk of metal. This also affects indoor work. If you've got an iron door for whatever reason, or a safe in the room, or a metal fence, but if you're out in a paddock, stock fences. You've got to be a certain distance away, at least 15 metres from a wire stock fence. Don't be closer than 50 metres to a shed or a set of stockyards. Windmills, likewise, lots of iron in windmills. They will mess with your compass reading. Take these things into account. Now, typically, if you're going for a walk to end feral biological items, your tool for doing so will typically have a chunk of iron in it, you need to separate your compass from that tool, or it will likewise give you a false reading. Okay, this is key. This is the legend, or parts of a legend, and I'll just show you where we find it. This is the legend where my mouse is moving now. Subset of this legend is here. Now, it's a translating tool or an index, and it matches pictures and words. So these pictures on the map actually indicate the word in the legend. So here we have a minor road. Here we have a main road through a built-up area because that's the red bit. Here we have an airport. There we have a power line. Look at that. There's that windmill that's going to, or a set of yards that's going to take away your correct compass reading. Okay. There's a fence line. Now, here's an interesting point. A horizontal control point. So we know them as trig points in slang because they're a known surveyed mark that the surveyors then use trigonometry to draw the rest of the map from, and they're typically at the top of a hill, and they will probably come with a height indicator as well. Okay, so legends are found at the bottom of the map. Legends for the maps that Mary has provided with us, that I haven't looked at, by the way, as yet, well, in any detail for this lesson, will probably have a legend on it or some sort of index to explain what the map is trying to tell you. Okay, so this is what we're here to talk about. Get a hold of the index or the legend that explains what the map is doing or trying to show you. Okay. Next, the legend will cover off on parts. The legend will cover off on things like roads, buildings, windmills, contour lines that I haven't discussed yet. Contour lines indicate height above sea level. We've talked about the other things. Okay, now, generally, built-up areas will tend to be coloured reddish. Non-built-up areas tend to be greenish. All water, including oceans and rivers, tend to be use blue to indicate them. Now, natural creeks and rivers will meander and follow a snake-like pattern courtesy of a combination of the curvature of the earth and the oscillation of the dipolar water molecule. That's why rivers bend. Canals or engineered rivers tend to be straight-ish, not quite like a Roman road, but not far from it. And again, they'll be coloured blue. So think along the lines of an irrigation canal, those sorts of things. Now, if you see something that's completely straight and blue and it's inland, it's not likely to be a river. Okay, lastly, our contour lines. A little bit about the contour lines. They are measured, they are typically indicated in meters, being in the French system. They indicate height above sea level, and the closer those lines are together, the steeper the slope. Therefore, a cliff or a mountain, or on the way to a mountain, is likely to have close contour lines. An open flat plain, you're going to have a long distance between the contour lines. So the flatter the country, the further apart the lines are. The steeper the country, the closer the contour lines are. Now, as an exercise, if you're still struggling a little bit with the concept, grab a map and just identify a couple of the symbols in the legend on the map itself. So from the marginal data to the big picture bit. Not a big exercise. Just get familiar with the symbols and then do that with the maps for the assignment. Now, your next lesson would cover protractors, degree compasses, mil compasses, the differences between pencils and crayons. In particular, crayons are not to be eaten. How you can divide a circle into 6,400 mils or 360 degrees, and the division of that is 17.7, not 18, but why we use that. And how if you walk on flat country in an unguided fashion, you'll almost always walk in a counterclockwise circle. And what you can do to avoid that. However, this will not be delivered in this series of lessons. It's way beyond the scope of the requirement for the course. This has been John signing off from Gimoy country, up with the Urujinji people and the Irukandji people. So I hope that this has been of some use. I'll run a Q&A later. Thanks for your trouble. Cheers.